Good morning. Welcome to the Select Committee on Energy Independence and Global Warming. All eyes are focused on the economic and environmental disaster unfolding in the Gulf of Mexico. The BP oil spill is causing an immediate human and ecological tragedy. The spill is yet another dramatic example of why we must find alternatives to oil. The American people are desperate for safe, clean energy alternatives, solutions that add jobs, end our oil addiction, and heed the warnings of climate scientists who have called for pollution reductions. 11 people tragically lost their lives in the BP rig explosion, and for the past week, an estimated 5,000 barrels of oil a day have been leaking into the ocean. As a result, the Gulf Coast fishing, seafood, and tourism industries are bracing for the worst. Wildlife refuges and marine sanctuaries remain in harm's way. Congress will keep a vigilant eye on BP's efforts to stop the leak and clean up this environmental mess. However, the visible oil is not the only carbon pollution we have to worry about. Once gasoline is burned in our cars and trucks, carbon dioxide is released into the atmosphere. We can see the oil slick in the Gulf from space, but it is the buildup of invisible carbon dioxide in our atmosphere that is preventing heat from escaping back into space. Even as carbon dioxide's concentration in the atmosphere has been accumulating, so has our scientific understanding of its effects and impacts. Based on over 150 years of scientific research, a clear picture has emerged of rising temperatures, increased droughts, severe rainstorms, and an acidifying ocean. Those who deny global warming point to past uncertainties that have been refuted. They ignore the overwhelming observational evidence that the increased levels of heat-trapping pollution are already warming the planet. Instead of trying to understand the science, they use stolen emails about analysis of tree rings in Siberia to turn an honest discussion into a Russian tree ring circus. Or they manufacture a cooling trend by cherry-picking a few years out of a longer record of warming temperatures. While the deniers hope to confuse the public, the real-world consequences of inaction mount. Over the weekend, killer storms blew through Tennessee, Mississippi, and Kentucky. In Nashville, nearly 13 inches of rain fell in just over 2 days' time, almost doubling the previous record that fell in the aftermath of a hurricane in 1979. These storms followed the wettest March on record in Boston. 2 50-year storms occurred within 2 weeks of each other. The National Guard was mobilized. Hundreds of people were evacuated from their homes. The region suffered millions of dollars in damages. No single rainstorm can be attributed to climate change, nor can a snowstorm disprove its existence. But the underlying science and the observed trends do point to more extreme weather events, especially heavy precipitation events, because a warmer atmosphere can hold more moisture. Extreme rainfall is just one of the consequences of the carbon polluters we are releasing into the air. Our witnesses today will explain how science has revealed this unseen pollution for what it is and discuss the very real consequences of its continuing accumulation in the atmosphere. As we approach summer, our clean energy debate needs to acknowledge what many would like to deny. Our dependence on oil carries with it national security, economic, and environmental risks. As gas prices rise and the oil slick spreads, perhaps we will finally acknowledge that we cannot drill our way to energy independence. We have 2% of proven oil reserves in the world. Perhaps we can also acknowledge the basic facts that have been known for decades. Increasing carbon pollution in the atmosphere is warming the planet, and that the only way to put a halt to such warming is to move to a clean energy solution. I would now like to turn and recognize the ranking member of the committee, the gentleman from Wisconsin, Mr. Sensenbrenner.
I thank the Chairman. When global warming alarmists tried to advance their agenda a decade ago, they pointed to a damning graph in the 2001 IPCC report that showed a sharp rise in temperatures over the past century. This graph is commonly known as the hockey stick, and it did a good job of scaring a lot of people, especially politicians. But the authors of the hockey stick may not have done a good job with their math. At least that's what a couple of enterprising researchers thought, and in double-checking the hockey stick data, Stephen McIntyre and Ross McKittrick showed that it wasn't as solid as previously thought. Lately, a lot of people have been taking a second look at the so-called settled science of climate change. Data collected by NASA may not be as reliable as once believed. And the ClimateGate scandal shows at best that some researchers did everything they could to prevent review of their work, and at worst, they outright sought to manipulate data. The debate on the accuracy of climate science is good for science. Proclamation that the science is settled are just politics. The shortfalls in the scientific record could have expensive consequences. Proponents of expensive regulatory reform must understand that they need more than political victories. The EPA's burdensome regulatory regime must be based on sound scientific foundation. The EPA's regulations will be predicated in large part on the IPCC's most recent report. So far, the list of errors in that report includes 1. A sloppily sourced claim that Himalayan glaciers would disappear by 2035. 2. Reliance on an unpublished study to claim the world has suffered rising costs due to catastrophic weather events, where the author later said there was insufficient evidence to support the claim. 3. Stating that 55% of the Netherlands is below sea level, when in fact only 26% is. 4. Failing to support the claim that Africa's agricultural output would be reduced by 50% by 2020. And 5, an unsupported claim that Bangladesh will be 17% underwater by 2050. A citizen's audit of the IPCC study found that 5,587 cited references, nearly a third of all the sources, were not peer-reviewed publications, but rather gray literature such as press releases, newspaper and magazine articles, discussion papers, master's and PhD theses, working papers, and advocacy literature published by environmental groups. These sources lack authoritative scientific rigor and are more often than not intended as propaganda. This week, the Inter-Academy Council said that it had picked a 12-member committee to conduct an independent review of the IPCC's procedures. Hopefully, the review will result in new methodologies that will give the public more confidence in the panel's conclusions before it releases its fifth assessment in 2014. The ClimateGate scandal brought serious questions about the reliability of data compiled by the Climatic Research Unit at the University of East Anglia. These emails showed a clear bias, a systematic suppression of dissenting opinion, intimidation of journal editors and journals that would deign to publish articles questioning the so-called consensus, manipulation of data and models, and possible criminal activity to evade legitimate requests for data and underlying computer codes filed under Freedom of Information Acts. One of these emailers called Stephen McIntyre a bozo for trying to hold him accountable for his work. Dr. McIntyre also reviewed NASA's temperature data sets. His work resulted in forcing NASA to change its history of U.S. temperature data to show that 1934, not 1998, was the hottest year on record. Another study shows that NASA may have cherry-picked weather stations to favor those that would produce higher temperatures than produce a record that's warmer than truthful. Internal emails also show that at least one senior NASA scientist raised questions about the accuracy of that agency's temperature data set. The IPCC report relies heavily on the CRU and NASA data to support its conclusions. And the questions raised about these data sets raise even more questions about the accuracy of the IPCC study. A report issued today by the Select Committee Republican staff shows that the EPA is violating its own rules by relying so heavily on the IPCC report. Both the EPA and the Office of Management and Budget Guidelines state that an agency must base any regulatory proposal on science that is clear and transparent. OMB guidelines further state that simply because a study is peer-reviewed doesn't mean that it fulfills the requirement that the results are transparent and replicable. I want to welcome here today Lord Christopher Monckton, the Chief Policy Advisor of the Science and Public Policy Institute. By helping to check and double-check the scientific literature, Lord Monckton is helping to improve the state of climate science, and I look forward to hearing both his perspective and the perspective of the other witnesses today. Thank you.
We thank the gentleman. The chair recognizes the gentleman from Oregon, Mr. Blumenauer.
Mr. Chairman, I will just reserve my time for the inquiry, as inviting as my good friend from Wisconsin's comments were. I'd rather save it.
Okay, the gentleman will reserve his time. The chair recognizes the gentleman from Washington State, Mr. Inslee.
I'll reserve as well. Thank you, Mr. Chairman.
Great, the gentleman's time is reserved. The chair recognizes the gentleman from Missouri, Mr. Cleaver.
Thank you, Mr. Chairman. Out of guilt, I will reserve as well.
Great. Chair recognizes the gentlelady from California, Ms. Spear.
Thank you, Mr. Chairman. I'm not going to reserve. I'm glad we're holding this hearing on the science of climate change. I welcome our scientific witnesses here today, and I look forward to relying on their expertise as we address the increasingly dire and challenging impacts of global warming. You know, I'm from the San Francisco Bay Area, where our most recognizable icon is the Golden Gate Bridge. A little known fact, however, is that just next to the bridge is our nation's oldest tidal gauge, a 150-year-old station that has given us the longest continuous tide record in the Western Hemisphere. The gauge shows an increased sea level rise of 8 inches over the past century, and the rate of that sea level rise has increased and is expected to accelerate further. In fact, the area is referred to as ground zero for sea level rise. San Francisco Airport and surrounding communities could be underwater by the end of the century. We in the Bay Area live on the edge. We know the seriousness of this problem for our ecosystem, our infrastructure, and our coastal and shoreline communities. In light of these most basic observations of our changing planet, acting on global warming in the here and now is just plain common sense. That said, the complexity of how we act on these changes demands our utmost attention. The sharp, tried and tested knowledge of our top scientists must be the foundation for our efforts to solve the climate crisis. I'm pleased we have some very qualified individuals here, and once again, I expect to learn much more from their testimony. I yield back.
Thank you. The gentlelady's time has expired, and all time for opening statements by the members has been completed. We'll now turn to our first witness this morning. He is Dr. Jim Hurl. Mr. Hurl is a senior scientist within the climate analysis section of the National Center for Atmospheric Research. His research focuses on climate variability and human-caused climate change. He has contributed to the Intergovernmental Panel on Climate Change, the IPCC assessments. He is also actively involved in the International Research Program on Climate Variability and Predictability. Dr. Hurl holds advanced degrees in atmospheric science from Purdue University. He is a fellow of the American Meteorological Society. We look forward to hearing your testimony. Dr. Hurl, whenever you're ready, please begin.
Thank you. Mr. Chairman, Ranking Member Sensenbrenner, and other members of the Select Committee, I thank you for the opportunity to speak today on observed and likely future changes in climate and the contribution from human activity to those changes. Although uncertainties exist, significant advances in the scientific understanding of climate change now make it clear that there has been a change in climate that goes beyond the range of natural variability, and this change is almost certainly due to human activities. This conclusion is drawn from multiple lines of evidence published in thousands of thoroughly reviewed scientific studies by many different investigators and independently assessed by many groups, including the U.S. National Academy of Science. The fact is that the globe is warming dramatically, and this change is already affecting both physical and biological systems. Global surface temperatures today are almost 1.5 degrees Fahrenheit warmer than at the beginning of the 20th century, and the rates of temperature rise are greatest in recent decades. 14 of the last 15 years are the warmest globally since 1850, and the last decade is 0.4 degrees Fahrenheit warmer than the 1990s. There is a very high degree of confidence in these numbers. Urban heat island effects, for instance, are real but very local, and they have been accounted for in the analysis. There is no urban heat effect over the oceans, where warming has also been very pronounced at both the surface and at depth. Moreover, warming ocean waters expand and thus contribute to sea level rise. Observed and accelerating melting of glaciers, ice caps, and ice sheets are also contributing by adding water to the ocean. Instrumental measurements of sea level indicate that the global average has increased over the last century, and the rate of sea level rise is increasing. Global sea level rise is probably the single best metric of the cumulative global warming, since it integrates the reactions from several different components of the climate system and is accurately observed from satellite instruments. Changes in global temperature or sea level do not imply, however, that changes are uniform around the globe. Regional differences arise from natural variability, and these effects can be large from year to year or even decade to decade. For instance, a historically large El Nino event helped make 1998 one of, if not the warmest year on record, while strong La Nina conditions contributed to relatively cooler worldwide conditions in 2008. Simply connecting these two data points in time, as was shown in the graph, has been done by some to misleadingly argue global warming has ceased, ignoring the fact that the longer-term temperature trend is clearly upward, and the years since 2000 have remained among the warmest on record. Because of such natural variations in the climate system, climate scientists expect occasional but temporary slowdowns in the rate of warming, even while greenhouse gas concentrations continue to increase. Climate models also predict such behavior, and today's best climate models are able to reproduce many of the observed changes in climate observed over the past century. Climate models are not perfect. Uncertainties arise from shortcomings in our understanding of climate processes and how to best represent them in models. Yet, the best climate models are extremely useful tools for understanding and determining the factors that are driving the observed warming. And the results are clear. The surface warming of recent decades, along with many other changes in climate, is mainly a response to increased concentrations of greenhouse gases in the atmosphere, which now far exceed pre-industrial values. In summary, the scientific understanding of climate change is sufficiently clear to show that climate change from global warming is already upon us. Many impacts are evident, and they will grow larger with time. Uncertainties do remain, especially regarding how climate will change at regional and local scales. But the climate is changing, and the rate of change is projected exceeds anything seen in nature in the past 10,000 years. Thank you again for this opportunity to address the committee, and I look forward to answering any questions.
Thank you, Doctor, very much. Our second witness today is Dr. James McCarthy. Dr. McCarthy is a professor of biological oceanography at Harvard University. He served as co-chair of the Impacts, Adaptation, and Vulnerability portion of the IPCC report, published in 2001. He was also one of the lead authors on the Arctic Climate Impact Assessment. Dr. McCarthy received his PhD from Scripps Institution of Oceanography. He is a former president of the American Association for the Advancement of Science, a fellow of the American Academy of Arts and Sciences, and a foreign member of the Royal Swedish Academy of Sciences. We welcome you, Dr. McCarthy. Whenever you feel ready, please begin.
Thank you. Good morning, Chairman Markey, Ranking Member Sensenbrenner, and other members of the committee. You ask us to address 4 questions.
Could you move the microphone in just a little closer, please? Okay, thank you.
You asked that we address 4 questions, and I've done this in my testimony, and so I will very briefly run through my responses to those questions. You asked that we talk about observations. How do we know that the climate is changing? What evidence do we have for attribution of these changes? And what are some of the anticipated impacts? And then finally, you ask how climate scientists should be furthering the understanding of climate change. So I'm an oceanographer. I've worked on all the oceans in my career. Ocean temperatures are changing in a way that could not have been imagined when I began my career as an oceanographer. I distinctly remember the day in 1986 when someone walked into my office and showed me the first graph suggesting ocean temperatures were changing. Now, people ask, how confident are we of these changes? If we look at the first slide, and these are the 4 graphics from my testimony, this shows the array of sensing instruments that are deployed in the ocean today. This is a snapshot from last month. There are over 3,000 buoys that have sensing devices that profile, move up and down in the upper ocean to depths of 6,000 feet, and they report their data by satellite to shore stations. So this is how we're tracking today the changes in ocean temperature, and are very confident that they're responding to the climate system. We know now that more than 90% of the heat that has been trapped in the atmosphere by the accumulating greenhouse gases is being stored in the ocean. The oceans are an intimate part of the climate system. Now, I'd like to say something about sea level rise, which has already been introduced by my colleague. In 2001, when the IPCC report was put to bed, it was estimated that sea level rise over the present century would be relatively modest, perhaps as small as 12 to 24 inches. But it was also not known how rapidly ice on Greenland and ice in the Antarctic could contribute to sea level rise. If you thought of a block of ice sitting on the counter and imagined turning up the temperature of the room, you would imagine it would melt faster. That would be true. But what we didn't understand was how it could become unstable and begin to lose ice to the ocean. And once in the ocean is warmer than the ice, it would melt even more rapidly. So if we look at estimates of sea level rise today, and first, if you look at the next graph, you could see if you go back to 1990, which is where the 3 dotted lines begin to span off to the right. These were the projections in 1990 of sea level rise from the IPCC. And you notice the red lines, which the tide gauge data referred to earlier by Congressman Speer. We see the blue line. These are the data which are now available from satellites, which are tracking ocean elevation far more precisely for a global computation than local estimates at tide gauge stations. And you'll see that the blue line extends up to the upper part of this curve, and the 3 bounds, the upper, the middle, and the lower lines of the dotted line, were the estimates in 1990. In other words, the IPCC underestimated quite starkly the rise in sea level. We now know data just in the last handful of years how rapidly Greenland and Antarctica are changing. And best estimates of sea level rise now for this century are between 2.5 and 3 feet. If we look at the next slide, you can see in the bars at the bottom the lower, higher emission, and even higher emission scenarios for the IPCC, and on the left are the sea level rise that was projected in feet. And the circles at the top show what would be estimated today if you included the melt from Greenland and Antarctica. And from this, you would see this estimate I gave of 2.5 or 3.5 feet. Next, I'd like to comment briefly on ocean chemistry. The carbon dioxide added to the ocean changes the balance in the mineral composition of what we call the carbonate system. Organisms in the ocean that make shells, whether they are snail-like animals that swim, there are one-cell plankton that have shells, we call them foraminifera and conchylotheriids, or corals, all make these shells out of calcium carbonate. Calcium carbonate is a very, very delicate balance in the ocean. The organism is taking the dissolved constituents out of the water, making its hard shell, but the water is trying to pull it back into solution, trying to redissolve it. So the organism is constantly working to accrete material, the ocean is trying to dissolve it. As you add carbon dioxide to the ocean, you change the composition, you change the relationship with this buffering system. It becomes more corrosive. It's referred to as ocean acidification. We know now that the rates at which this is changing are faster than any time in the history that we can reconstruct over the last several million years. Now, just finally, I'm going to say something about the distribution of organisms. This is very close to where Congressman Markey and I live, which shows in the lower graph how the distribution of cod would change with the warming that's expected. So let me just conclude by saying that these changes are in the scientific literature. beyond all bounds of historic record. And I'd just like to comment with an opinion in response to your last question that I think climate scientists have an obligation to do everything we can to help convey clearly this message to the public. Thank you.
Thank you, Dr. McCarthy, very much. Our third witness is Lord Christopher Monckton. He is Chief Policy Advisor for the Science and Public Policy Institute. He holds a diploma in journalism from the University College Cardiff. He has worked as an editor at various news outlets, including The Universe, The Telegraph, Sunday Magazine. Today, newspaper, and the Evening Standard. From 1982 to 1986, he was an advisor to UK Prime Minister Margaret Thatcher and gave policy advice on a variety of issues. He is a founder and director of Christopher Monckton Limited, which consults in public administration. We welcome you, sir. Whenever you're ready, please begin.
Mr. Chairman, sir, and Ranking Member Sensenbrenner, it's a pleasure to see you both again and also many other faces on your committee. Thank you for having the courtesy to ask me to testify in front of you. I'm going to testify not, of course, as a scientist, because I'm not one, but as a policymaker. And the role of policymakers when confronted with scientists is to know what questions to ask. And I'm going to raise one or two questions now about some of the evidence you've already heard. If you look at the slide now before you, that slide purports but does not demonstrate that the rate of global warming is itself increasing. This is taken from the IPCC's 2007 report, where it appears 3 times large and in full color. However, it relies on a bogus statistical technique, which is applying multiple trend lines to a single stochastic data set, and if you choose your starting and ending points carefully enough, you can make it go in any direction you want. This graph is regularly relied upon by Mr. Pachori of the IPCC. I challenged him on it recently in Copenhagen. It's also relied upon by the EPA. It is defective, as I shall now show. Next one, please. This graph is the same data, but this time with different trend lines on it. From 1905 to 1945, you will see that the temperature rose faster than from 1905 to 2005. Does this mean that the rate of global warming is slowing down? No, it doesn't. Both this graph and the previous one are bogus, but they're using the same technique on the same data to produce opposite conclusions. That is why the IPCC should not have used that first graph, which has been so heavily relied upon. Let us now see what the true position is. Next slide, please. You will see, in fact, there have been 3 periods of quite rapid warming over the last 150 years, 1860 to 1880, 1910 to 1940, and 1976 to 2001. Those 3 rates of warming are exactly parallel, though recently when Senator Vitter questioned Mr. John Holdren about this, he tried to claim that the 3rd rate of increase was greater than the other 2. It isn't. They're exactly parallel at roughly 1.6 Celsius per century. Now, we can't explain what caused the first 2 rapid rates of warming because we didn't have the instrumentation to find out. However, in the satellite era, to the right of the green vertical line there, we are able to observe what caused most of the 3rd piece of rapid warming. Next slide, please. And this is from a paper by Dr. Claire Pinker and her colleagues in 2005, showing a very rapid increase in what's called global brightening, the amount of sunlight actually reaching the surface of the Earth. Enough global brightening, in fact, to cause a warming of 1 Celsius degree, though only 0.37 Celsius degrees was observed over that 18-year period. So if anyone tries to tell you that we cannot explain the global warming of the last 30 years except by reference to carbon dioxide, this graph and many others like it in the scientific literature should suggest otherwise. Next slide, please. And if we now include that data from Dr. Pinker together with the various forcings and temperature increases from the individual greenhouse gases, we will see that what we end up with is a 4-fold overstatement of the rate of increase in global temperature that was actually observed if we use the IPCC's methods to calculate what the warming would have been, a 4-fold exaggeration. Next slide, please. And this result is confirmed most recently by Professor Richard Lindzen and his colleague Young-Sang Choi in a paper published in 2009 and published again this year, showing 11 models all predicting various rates of warming from 1.4 to infinity Kelvin if you double CO2 concentration. Next slide, please. The reality, however, is just 0.7, which is less than a quarter of what the UN would predict for a doubling of CO2 concentration. The conclusion from this is that we can explain the warming by other methods. Not very much warming is going to happen, and therefore one should be very careful before spending money, next slide please, on cap and trade. Because even if we were to shut down the entire global economy for 23 years, all you would forestall is 1 Fahrenheit degree of global warming, even if the UN is right in estimating the amount of warming from CO2. Therefore, the correct policy is to have the courage to do nothing. You will lose nothing thereby. There are many other problems to address. I would recommend you address those and not this.
Thank you, Log Moncton, very much. Our fourth witness today is Dr. Chris Field. Dr. Field is the founding director of the Carnegie Institution's Department of Global Ecology. He is also a professor of biology and environmental earth science at Stanford University. He was a coordinating lead author for the 2007 Fourth Assessment Report of the Intergovernmental Panel on Climate Change. Currently, he is co-chair of the Impacts, Adaptation, and Vulnerability portion of the upcoming IPCC report. Dr. Field received his PhD from Stanford in 1981. Among his many distinctions, he is a member of the National Academy of Sciences. We welcome you, Dr. Field.
Thank you, Chairman Markey, Ranking Member Sensenbrenner, and other distinguished members of the committee. What I'd like to do today is take a couple of minutes to talk about observed changes in the climate system. I won't be focusing at all on projections, but only things that have been observed and are clear in the record. If I could have the slides, please. As Dr. Hurl has said, it's very clear that during the period when we've had good instrumental records from weather stations, the global climate has warmed. The record you see here is the land temperatures from all the world's meteorological stations. Since the late 19th century, the warming has been about 1.5 Fahrenheit, with all of the warmest years in the record in the last dozen. 2009, based on the data from the NASA Goddard Institute for Space Studies, was the third warmest year on record. If we look at the United States, next slide please, you see a very similar pattern, but with a lot more jumpiness, as you would expect for a region that represents only about 2% of the planet's surface. What I'd like to do is spend a couple of minutes talking about whether there are other ways we could infer whether or not the climate's changed. Is nature telling us how climate's changed? And the next slide, please, gives an overview of what the IPCC has concluded. We have a wide range of observations now spanning many decades and on a tremendous number of physical and biological systems. These are things like what are the locations of the snouts of glaciers, what are the times when buds burst or when flowers flower. The IPCC examined a bunch of these records and concluded that there were over 29,000 statistically significant changes in these physical and biological systems. And then it said, well, which of these are changing in the direction that's consistent with climate change being the forcing, and which are changing in the direction that's not consistent? The overwhelming conclusion is that the vast majority of these natural thermometers are indicating that global warming is occurring. Fully 94% of the statistically significant changes in physical systems are consistent with global warming. Fully 90% of the statistically significant trends in biological systems are consistent with global warming. One couldn't look at any single one of these trends and conclude that it's proof that the climate system is warming. But when you step back and look at all 29,000, there's a tremendous level of confidence in the numbers. Now, a lot of these trends are issues that don't necessarily have a lot of traction on human systems, but I want to focus on 3 that do. Next slide, please. Most states in the American West get at least half of their water supply for summertime from snowpack. and we've seen dramatic changes in the water content of the spring snowpack, the April 1st snowpack, over the last 50 years. In the Pacific Northwest, there's been a decrease of about 30%. In the interior ranges, there's been a decrease of about 20%. This is the water supply that water-short regions depend on in order to make it through the summer, and over the last 50 years, we've seen profound decreases. Next slide, please. Another impact that's really clear from the data is that wildfires have been increasing across the American West, and that the frequency of wildfires is strongly sensitive to temperature anomalies. What you can see in the plot is that the black line tracing annual temperature almost traces precisely the variation in the number of wildfires. Essentially, the risk of wildfires goes up dramatically as the temperature goes up. A third observed trend I want to talk about is in the next slide, and this is the trend of observed changes in the days with the heaviest precipitation. What you can see is that from the middle of the last century, there has been a 67% increase in the days with the heaviest precipitation in New England. Over all of the eastern U.S., there's been at least a 20% increase in days with heavy precipitation. Heavy precipitation is essentially the driving force for the kinds of floods that we have seen in Tennessee recently. We can't look at any single weather event and ascribe it with 100% confidence to climate. But what we can see is that this kind of change in the climate system is increasing the risk of damaging weather events. I think that all of us would agree that you can't get in a car with a bald tire and have confidence that you're going to have an accident, but you can say that you would consider the risk unacceptable. With climate, I think it's very clear that we've now pushed the system to a point where it basically has 4 bald tires and a flashing check engine light. Thank you very much.
Great. Thank you, Dr. Field, very much. And our final witness today is Dr. Lisa Gromlich. Dr. Gromlich is the director of the School of Natural Resources and the Environment at the University of Arizona. Her research focuses on the interplay of global climate change and natural resources management. She has also directed the University of Arizona's Institute for the Study of Planet Earth and Montana State University's Big Sky Institute. Recently, she served on the Oxborough Inquiry panel that reviewed the scientific work of the University of East Anglia's Climate Research Unit following the release of private emails of some of their scientists. Dr. Gromlich received her PhD from the College of Forest Resources at the University of Washington. She is a fellow of the American Association for the Advancement of Science. We welcome you, Dr. Gromlich.
Chairman Markey and Ranking Member Sensenbrenner and the rest of the members of the committee, thank you so much for inviting me to speak with you today in this very important hearing. In what I'm going to say today and in my written testimony, I have focused on the observational record of current and past climate variability, and I do that as a tree ring scientist, as a dendrochronologist by training. And I want to spend a moment talking a bit about the kind of perspective that one brings to this question as someone that has looked at tree ring records of the past. And I'm going to take you back in time 20 years when I was an assistant professor at UCLA. As a tree ring scientist, I was off to the Sierra Nevada to look for very, very old trees, and in fact found them, very, very old foxtail pines, relatives of bristlecone pines, high up at upper tree line in the Sierra Nevada. But what shocked me when I got there was not the old trees, I expected to find those there, but as you went above tree line, there were very large dead trees. I mean, very large dead trees above current tree line. Not just a couple, hundreds of them. And what that meant was that in previous eras, tree line had been higher, implying that temperatures had been warmer. So as a trained tree ring scientist, it turns out that we can very accurately date the innermost ring of those dead trees that tells us when the trees were established, and the outermost ring, which with a little sort of 50-year or so error because of the loss of sapwood, tells us when those trees died. So what we know is over the last 3,000 years, tree line was higher, and then somewhere around 950 AD, there was this massive die-off and tree line reestablished at the current rate. So went back to the lab, started looking at those data, and started to also reflect on the fact that if you thought about those dates were very consistent with the time in which the Norse Vikings colonized Greenland and Iceland, and the dates at which my trees died were about the same time those colonies failed. So, recall this is 20 years ago, there were the two outcomes. One is that I became fascinated with what caused these long-term variability in climate. But the second outcome that is apropos today was that I was very much struck by the fact that when I described my research to the public, it was very clear that it appeared to them that I had this very strong ability to say that, yes, current climate trends were well within the envelope of natural variability because I had trees in the Sierra Nevada and historical data in the North Atlantic. That is not climate science. That is assembly of a couple of just-so stories that tell us something about climate at two places on the first surface of the Earth. And what has happened subsequently is that, along with dozens of colleagues, we have very carefully scanned the Earth for other kinds of high-resolution proxy data, tree ring records, historical documents, speleothems, ice cores, any number of varve sediments, to try to understand how they reflect or don't reflect temperature data. In doing that, we discovered that, in fact, there were a couple of other places around the globe that had this medieval warm period, in particular the Eurasian part of the Arctic and parts of course, the North Atlantic and the western part of the U.S. In other places, like the Northwest, the tropical Pacific, temperatures were actually cooler during the so-called medieval warm period. And that this dozens and dozens of peer-reviewed studies have allowed us to be able to assert with great confidence after 20 years of looking for these kinds of records that, in fact, the late 20th century is the warmest period of Earth history in the last 500 to 1,000 years. So finally, it is these kind of data that were assembled by the Climatic Research Unit at the University of East Anglia. I had the opportunity to participate as one of the panel members in Lord Oxborough's scientific assessment panel. And in looking at that, and I want to quote the key response, is that we saw no evidence of any deliberate scientific malpractice in any of the work of the Climate Research Unit, and had it been there, we believe that we would have detected it. Rather, we found a small group of dedicated, if slightly disorganized, researchers who were ill-prepared for being the focus of public attention. The full report from that panel is appended to my own testimony. Thank you.
Thank you, Dr. Gromlich, very much. The chair will now recognize himself for a round of questions. Today is Election Day in the United Kingdom, and it is unclear which party will emerge as the winner. What is clear is that the leaders of the three major parties believe carbon pollution must be addressed. Nick Clegg, the leader of the Liberal Democrats, has said climate change scientists now agree that time is running out. The next Parliament is the last chance we have as a nation to introduce the bold measures of radical legislation leading us to set us on the path to green and sustainable growth in the future. Gordon Brown, leader of the Labour Party, has said, everybody knows the importance of climate change. It is one of the key issues that has moved me most and has made me determined to act internationally as well as nationally over the past few years. David Cameron, leader of the Conservatives, has said, we all agree that climate change is one of the greatest and most daunting challenges of our age. We have a moral imperative to act and act now. And this concern about global warming is not new for British politicians. Please play the videotape.
The danger of global warming is as yet unseen, but real enough for us to make changes and sacrifices so that we do not live at the expense of future generations. That prospect is a new factor in human affairs. It's comparable in its implications to the discovery of how to split the atom. Indeed, its results could be even more far-reaching.
So, Dr. Hurl, despite all the stolen email, IPCC issues, what is your conclusion in terms of the strength of the case that has been made that global warming is real and that the consequences are catastrophic?
I very much agree with those conclusions. I think, as I tried to state in both my written and my oral testimony, much of the strength lies not in individual papers, individual data sets, individual analyses, but rather the fact that there are many multiple lines of evidence conducted by multiple investigators, as we heard in the other oral testimonies, spanning many different physical and biological variables that all give a very consistent picture of global warming, of a warming world. And the science is advanced to the point that we can clearly attribute these changes to human activities and in particular the buildup of greenhouse gases in the atmosphere.
Dr. McCarthy, Lord Monckton had a very complicated explanation of the global temperature record. Can you tell us simply what is happening in the global temperature record and if it is attributable to human activities?
There have been a number of efforts over the last maybe 10 to 15 years to use the knowledge we have of what could change climate, and some of these factors are referred to by Mr. Monckton. We know that greenhouse gases influence climate. We know that clouds influence climate. We know that solar variability can influence climate. And we know that there are natural cycles referred to earlier as, for example, the El Nino cycle. And when you use these known aspects of climate to reconstruct climate over the last few decades, you find that there aren't big missing pieces, that the changes in climate that we have observed can be explained. Why was 1998 such an exceptionally warm year? It's already referred to Jim Harrell, a year of an exceptionally warm, probably the warmest El Nino that we know for the last several hundred years. Why was 1992, 1993, 1994 unusually cool relative to the years before? Immediately following the eruption of Mount Pinatubo, the largest volcano to have affected climate. Our most recent volcano that was very much in the news will probably not have much effect on climate because the release of material from that volcano was low in the atmosphere, and of course we know interrupted air traffic. So when you put these pieces together, you find that there aren't big gaps. There aren't periods where you can't explain how climate has changed. Now, when you go back further in time, it becomes more difficult. But if you mark from like 1980, which is when we have satellite observations of Earth's surface, satellite observations of ice, in 1991, when Mount Pinatubo was erupted, satellites could measure directly its contributions to the upper atmosphere. When you put these pieces together, there are no great mysteries about how climate has changed over the last 10 to 20 years, and it's entirely consistent with the forcing by greenhouse gases.
And Dr. Field, why don't you just quickly try to answer that question as well?
You know, one of the major focal areas in climate science over the last several decades has been a topic that's called fingerprinting. How could we really be sure that the climate change that's now unequivocal is a consequence of human actions? And there are a large number of independent climate fingerprints for human action, most of which don't require fancy climate models at all. A good example of a fingerprint is that if climate change is caused by greenhouse gases, we expect most of the warming to be in the lower atmosphere with cooling in the upper atmosphere, exactly as we see. Dr. McCarthy already mentioned this balance between the heat that you calculate should be in the climate system and the amount of heat that we actually see in the oceans. These fingerprinting techniques are very, very powerful at discriminating alternative explanations, and they point overwhelmingly at the human release of heat-trapping gases as the dominant cause of warming over the last half-century.
And you agree, Dr. Grumlich?
Yes, I do.
Let me ask this. Do you each disagree with Lord Monckton's analysis of whether or not, in fact, there is a global warming trend and that it is a danger to the planet? Do you disagree with him, Dr. Hurl?
Yes, I do.
Dr. McCarthy?
Mr. Monckton said he's not a scientist. He works in the policy arena, and on the basis of the science as he reads it, he doesn't think it calls for policy action. I think most scientists who look at the data believe that it does need policy action.
Thank you. Dr. Field.
Many scientists have looked at the issue. Warming is unequivocal. The evidence for the human fingerprint is very, very strong, and the prospect of continued warming in the future is very strong.
So you do disagree with Lord Monckton?
Disagree with Lord Monckton.
Dr. Gromlich?
I disagree with Lord Monckton's conclusions based on the evidence that he presented as well.
Okay, thank you. My time has expired. Let me turn and recognize the gentleman from Wisconsin, Mr. Sensenbrenner.
Thank you very much, Mr. Chairman. Dr. Gromlich, you were on the Oxborough panel, weren't you?
Yes, I was.
Okay. Do you have a professional relationship with any of the scientists who were criticized during ClimateGate?
I, as a member of the paleoclimatic community, have an acquaintanceship with many of the people that were mentioned in the emails. You're probably aware that both Dr. Malcolm Hughes and I are from the University of Arizona, and that we both have professional relationships with the Laboratory of Tree Ring Research there.
Have you co-authored papers with Dr. Hughes?
I have co-authored one book chapter with Dr. Hughes.
Has your work relied on information or data from the CRU?
No, it hasn't.
Pardon?
No, it hasn't.
Okay. The tree ring data and the hockey stick graph were directly called into question by ClimateGate. Have you relied on any of that in any of your professional work?
The data that myself and my students have produced have been at times part of these very, very large compilations of data that have allowed us to assess the nature of climate variability over the last 500 to 1,000 years. The hockey stick per se is never quoted in my own professional work.
Okay. What did the panel learn from critics of the CRU's scientists during its review?
What I think the panel took away from the critics of the CRU scientists is that, in particular, that what we discovered was that, for example, the archiving of raw data and the development of documentation on computer code such that it could be widely distributed and understood by the general public was something that for years had not really been a high priority. Often it was unfunded by the kind of scientific funding sources that were available. And what was clear to the panel was that the stolen emails, as well as other things, other events had motivated both scientists and science funders to do more public archiving of data.
Did the panel interview any of the critics of the CRU data?
No, that wasn't our charge. We were charged to look at
Well, why not? How can you get an objective viewpoint if you just look at one side of the issue?
The charge to the panel was to look at the scientific integrity of the publications of the CR unit, and we fulfilled that charge.
Well, then that was an extremely limited charge, that preordained a conclusion. Was there any analysis of the actual emails or the biases that they exposed?
That was not part of our charge.
Okay.
And that was actually part of other kinds of inquiries that have gone on.
Now, were you aware of any of the biases of the other members of this 7-person panel?
I believe that the panel was chosen to minimize bias.
Well, Lord Oxborough has strong personal and financial interests in anti-global warming policy. He's director of an international environmental organization called Globe International. He's also chairman of a green energy firm called Falk Renewables and president of the Carbon Capture Storage Association. And there was an article that appeared in the Times of London on April 14th where Lord Oxborough himself even told the university that he was unfit to chair the panel because of conflicts of interest, and warning the UEA that people might question his independence. Were any of those issues raised, either on Lord Oxborough or any of the other members of the panel?
Those issues weren't raised. What we were focusing on was the science of the climate research unit as revealed in their publication record and in their day-to-day operations.
Didn't
Lord Oxborough was actually functioned very much as someone who has a PhD in earth sciences and brought his scientific mindset to that task.
Well, if he's a director of an advocacy organization called Globe International, that I've had meetings with and tiffs with ever since Kyoto, together with the intertwining of you and other members, I don't think that this was an objective review. I don't know how universities in the United Kingdom get to the bottom of potential scandals, but I don't think our news media here in the United States would allow any university to get away with a panel that would come to a preordained conclusion, and I yield back the balance of my time.
I guess I'm having these terms echoing in my ear. I mean, it seems to me that it's a very stark difference. Dr. Gromlich, you were talking about focusing on the science. Our purpose today was to do precisely that, and I find it a little embarrassing and sad that the minority's witness is a journalist with no scientific training who didn't come here with any information against the science. It has been intriguing to me. I've heard Mr. Mockton, I've often thought appropriately named in the past, and it's entertaining, but it doesn't deal very much with the essence of what we're talking about here. My sense is that it wasn't, Dr. Gromlich, there were several other studies. There's been one by the British House of Commons. There's been one by the university itself, if I understand it correctly, one by Penn State.
Yes.
All have looked at the science.
Right.
And concluded that this is a tempest in a teapot. I mean, there's nothing here that contradicts the basic science that has been reiterated by the other three distinguished scientists that join you on the panel. Is that correct?
That is correct, and if I could add to the list of reviews that have happened at my own institution, the University of Arizona, at the request of the president, all of the email, an inquiry was made. Every single email was read, including those that dealt with Dr. Hughes, and there was a finding that there was no impropriety that affected the scientific conclusions of Dr. Hughes and others.
Yeah. Though I suppose I should declare, for the purposes of the record, I have worked with Globe International in other areas dealing, for instance, with serious problems dealing with international water supplies. I don't think it has affected my objectivity, nor did I notice any sinister underlying motives or an international agenda at work. Dr. McCarthy, it's good to see you again. I'm struck, we first met in your office 10, 12 years ago, where you were kind enough to help sort of walk me through some of these issues. In the course of those 10 or 12 years, not going back now to '86 when you talked about the trends that first sort of caught your attention, but just in the 10 or 12 years since we first met, have you seen anything in terms of the trend lines? Could you talk about whether that has gotten more urgent or less in that decade or more?
Congressman, one thing I remember quite distinctly was our discussion about infrastructure and wondering the degree to which planning, particularly for built infrastructure, the bridges, tunnels, mass transit systems, utilities of all sorts, should begin to take into consideration for our coastal cities the prospect of sea level rise. And at that time, I can only guess that I would have said, well, this is something that we need to be concerned about in the future. But if you took the best estimates of the IPCC at that time, the planning horizons were out many decades. Now, that's all become very compressed in time in the last decade because of the new knowledge of the rate at which ice loss is going to affect sea level rise. So you look at any of our coastal cities, if you look at the shape of Florida with 2.5 or 3.5 feet of sea level rise a century, it's a very different looking Florida. And although you think that rise, just the height of the counter here is not a lot, but when you consider low-lying land and how far that reaches inland, our Gulf Coast, very much in the news these days, will be dramatically affected by a sea level rise of that sort. And of course, there are entire island nations that, with the combination of sea level rise and the loss of coral through the change of pH in the ocean, will be at risk. So that would be my biggest sense of change. And of course, in that period, as has been pointed out, we have seen temperature record after temperature record broken for the global average temperature.
And in terms of the, quote, mistakes of the IPCC, I mean, what you have demonstrated with your testimony is that a mistake, that the studies, the projections were actually very conservative.
People tend not to appreciate how conservative the IPCC process is. When you get a bunch of scientists together and get them to agree on a statement, trimming as many caveats out as you can, because the scientists always want to add caveats. Well, we're not entirely sure, but this would be what we would expect. You end up with a conservative statement. You end up without extremes on either side being represented. In this case, in sea level, it was a very conservative statement.
Thank you. And it is, in terms of the risk that are at stake, we take in the Northwest very seriously that diminution of the snowpack, the less water content, pretty dramatic just in the community that I live in. And the fact that more than half the American population is in the 673 coastal counties, when you're talking about inches, let alone feet, this is pretty compelling, at least in my mind. But the point, I guess, in terms of a policy perspective, based on the potential risks, based on the economic, the security problems, and just the waste of resources, is there any good scientific reason not to advance sound policies, even if we weren't concerned about global warming? Stunned silence. All right.
Sorry, who is being addressed?
That's fine.
Who are we addressing?
Why don't we, I will turn to Mr. Shattuck for your inquiry.
Thank you, Mr. Acting Chairman, if that's what you are. First, let me begin by apologizing. I have had to duck out in and out a couple times because I have another hearing going forward downstairs on the healthcare issue. Second, I want to welcome Dr. Gramulik. You are now at my alma mater, the University of Arizona, where I received both my undergraduate and law degree, and I'm pleased to have you here and proud of the University of Arizona and proud of it being recognized for the knowledge and skill of its scientists and professors. I guess I have to begin, Dr. Moncton, by expressing a little shock at the questioning that just went forward and some reference to your name. I think that's a little inappropriate, but if that's what we're going to do in this hearing, so be it. I do believe you were just told that because you're not a scientist, you didn't bring forward any scientific information or any information of any value to this hearing. Somehow I don't seem to agree with that. I think you brought forth an analysis of scientific information, which I thought was fairly clear, and I guess I'd like to see you at least have an opportunity to repaint that picture, because apparently some people in the room didn't understand that what you said was, here is scientific data, here is how it was presented, here is the conclusion that was drawn from that scientific data, and here is why that conclusion is in fact unsupported. And apparently that escaped the attention or the understanding of some people here. Is there a possibility we could call that graph back up and you could explain it to us?
May we have the slides again,
Maybe we
please?
can get it the second time.
I'm most grateful. I think that obviously what is happening here is there's a certain amount of politics has crept in on one side of this debate.
What a shock.
And therefore, inconvenient science has been dismissed as not being science at all. That is the IPCC's graph with the 4 separate trend lines on it. That, as I've said, is an inappropriate statistical technique. Next slide
Wait,
again.
just while
Let's
we're
go
on
back.
that one.
Yeah.
The purpose of those lines, this actually appears in the IPCC report.
It does 3 times, yes.
And all those lines slope upward at different angles.
That's right. As you get
And are-
nearer to the present, they slope up at steeper and steeper angles. The implication, which is stated 3 times in the report, being that there is an acceleration of the rate of global warming. No, there isn't, as we see from the subsequent slides. First of all, if you choose different starting points and ending points for where you do your trend lines, you can make the lines go completely, make the trend go in completely the other direction. There, you've got 1905 to 1945. It was warming at twice the rate of 1905 to 2005.
So it's the exact same data.
Same data, same technique. It's a bogus technique, of course, and that's why you get completely opposite results depending on where you choose to start and end your trend line.
Incorrectly analyzed in the earlier graph to show
Exactly.
a rapid increase in warming.
Exactly, and incorrectly analyzed again here.
Okay.
Next slide. Here is the true position, where you have the 3 parallel rapid rates of warming. The first 2 cannot have been caused by CO2 on any view. The increase in CO2 over those periods wasn't enough, even on the UN's formula, to cause that. The third one, we know, was largely caused, because it falls in the satellite era, largely caused by a naturally occurring decrease in cloud cover, chiefly in the tropics, allowing more sunlight to hit the ground. And that, if you use the UN's multiplying up of the warming effect of that, should have caused 1 Celsius degree, or 1.8 Fahrenheit of warming. Only 0.37 Celsius was in fact observed. So we now know that that third of the 3 rapid rates of warming was caused by a natural event almost entirely.
Could you clarify something for
Of course.
The panel and for the people in the room listening? What is the satellite era?
The satellite era, from about 1983 onwards, we had satellites up there not only measuring changes in global surface temperature, which they do by reference to platinum resistance thermometers, comparing that with the temperatures they see on the ground, but also changes in outgoing radiation and changes in cloud cover. And all of these satellite data show us exactly what has caused the warming of that most recent rapid period, and it was largely, in fact very nearly all, to do with the reduction in cloud cover that happened quite naturally over the period, nothing to do with CO2.
And with regard to, you don't take the position that there has not been warming.
There has been warming. You can see it on the graph there. Of course there's been warming. Mr. Chairman, you got that slightly wrong when you said I didn't say there's been warming. Of course there's been warming. What I'm saying is that in the one period we can tell about what caused the warming, the satellite period, it is clear that the warming was largely naturally caused. And there's paper after paper in the literature establishing this. Go on again, please. Next slide. This is Dr. Pinker's paper establishing that the warming of that period was caused largely by a naturally occurring reduction in cloud cover, extra sunlight reaching the ground. Next slide, please. And next one, we'll miss that one out. We'll go on here to the 11 models, I should say, all predicting very, very rapid rates of warming. But this is the relationship between warming at the surface and extra outgoing long-wave radiation. Most of the models predict there will be less radiation escape into space if you warm the surface. The truth, however, as you see in the middle panel now, that's the Earth Radiation Budget Experiment satellite measurement. It shows a very rapid increase in the amount of outgoing radiation escaping to space as you warm the surface. What that means, very simply, is that the radiation isn't being trapped down here to cause warming at anything like the rate that the UN predicts. And that's why Professor Lindzen of MIT has concluded that the amount of warming you can expect to get from a doubling of CO2 concentration, this is scientific measurement, not playing with Xbox 360 models, is only 0.7 Kelvin compared with the 3.26 plus or minus 0.69, which is the best estimate of the UN's climate panel. Now, 0.7 Kelvin for a doubling of CO2 concentration is small, harmless, and generally beneficial.
I thank the gentleman, and I appreciate the indulgence of the chair in allowing you to answer. I guess your conclusion was, I'll just conclude with this remark, that we should do nothing. Certainly it appears to me that the majority got to pick 4 witnesses here. We got to pick 1 witness here. It's pretty evident to me that whether we do nothing or what we do, there's clearly at least a dispute about the evidence. And it is not, in fact, apparently agreed upon. Mr. Chairman, I would also like at some point to ask unanimous consent to put into the record the actual emails which were exchanged, which I believe show the dialogue going on with regard to the analysis of the IPCC report.
Without objection, it will be included in the record. The gentleman's time has expired. The chair recognizes the gentleman from Washington State, Mr. Inslee.
And I would note there is a dispute about whether we actually landed on the moon, and there is a dispute about whether the Earth is round, and there is a dispute about gravity in some places. But there is no... We'll get to you, Lord Monckton, shortly, but I want to talk to the scientists on the panels first, if that's okay. Thank you very much. Dr. McCarthy, I appreciate you bringing up the ocean acidification issue, which Dr. Jane Lubchenco of NOAA has called the evil twin of climate change. And I'd like you to describe what actually happens to species when they are exposed. And I want to put up a slide that I believe I got from Dr. Lubchenco. This slide basically shows what happens when you put a pteropod, a small a creature, in the water. On the left, you see its picture. These are relatively small, and this shows what happens when you put a pteropod in water that will be in the same acidic conditions that will exist in the year 2100 if we do not change our course. So it basically shows that, according to Dr. Lubchenco, the pteropod melts. Its little calcium carbonate structure actually melts. And I just wonder if you can describe what the oceans will look like from an acidity standpoint in the next 100 years if we don't change course, and what that does to the plankton that serves or could do to the bottom of the food chain.
Thank you. This, like a lot of the other change we're talking about, is not simply a difference of one condition to another, but the time period over which it happens. So if we look at changes in the ocean over the last million years, every 100,000 years or so, we saw ice advance, retreat. We saw organisms that lived in the high north moving closer to the equator during the cool periods, moving back on land and in the ocean. In fact, it's interesting, there are very, very few extinctions in that period. That the memory, the genetics of organisms know in their history that being able to accommodate those changes is essential for survival. But when you crank those rates of change up, pH changed during those periods, temperature changed. When you crank those rates of change up 100 or close to 1,000-fold in some cases, then you exceed the capacity of ecosystems to adjust. Now, in this case, the pteropod, I was tempted to put a picture of a colorful animal here. Pteropods are absolutely beautiful animals, and if you could have one here in a beaker, the foot of the mollusk is thin and flaps like a wing. They're called sea butterflies. You ever see them swimming? They're just spectacularly beautiful with this very delicate shell. They're a very, very important part of the food web in the North Pacific, particularly for salmon. We know that the pink salmon depends heavily on the pteropod for its food. Now, it's just one example. I mentioned others. A microscopic plankton, the foraminifera, coccolithophorids, and of course corals are all subject to this same condition. That is, as carbon dioxide is added to the ocean more rapidly than it can adjust. And if this were being added over thousands of years rather than over 100, it would be a whole different story. More rapidly adjust, then the constant tension of the animal of trying to keep its skeletal material, its shell, from dissolving becomes more and more in the favor of water. That is, water pulls those minerals back into solution. So this is the condition. And of course, we know in the past there's been more carbon dioxide in the atmosphere. We know that in the past, pH of the oceans has been different. We also know that there are periods in the past where organisms like this disappeared, that the conditions were not suitable for corals or mollusks to survive. So this is a very important issue.
So I'm told that the waters are more acidic, 30% more acidic than they were in pre-industrial times. What will they be at the end of the century, approximately, if things don't change?
Well, I don't know how to express it in terms of percent, but if you take these extrapolations, as is done here experimentally, you can show what the effect would be of that changing acid-base balance, referred to in the vernacular as acidification. The oceans aren't becoming acid; they're becoming less alkaline, but it will dissolve these minerals.
Thank you. I was impressed. We're here as the House of Representatives to have the state of the science discussed about climate change. And I was impressed that those who have denied the threat this poses to the planet Earth couldn't produce one scientist, not one scientist, to propose a hypothesis to explain what the Earth is undergoing, all the changes we're undergoing now. They produced somebody that doesn't even have a background in scientists. And that's what they produced to try to convince Americans that somehow that this is a big hoax. I think that's impressive or unimpressive, depending how you look at it. So I want to ask about Lord Monckton's viewpoint and basis for that. Lord Monckton, when did you start serving in the House of Lords? I noticed you brought fraternal greetings from the Mother of Parliaments to Congress, to our athletic democracy. When did you start serving in the House of Lords?
Sir, I have never sat or voted in the House of Lords, as you have probably been informed.
Thank you.
The
So basically, I want to understand.
House of Lords Act.
Thank you. You've answered my question.
Yes.
You come here, you call yourself a lord to try to convince the world to ignore something that threatens our grandkids, and you're not even a lord. Not only let me finish my question, then I'll let you speak.
Just one moment, sir.
No, excuse me, Lord Monckton, excuse me, in our athletic democracy, we'll ask the questions and you'll answer them. Thank you very much.
Very well, but you must not misstate, please, sir.
Excuse me. You come to our athletic democracy, sir, calling yourself Lord Monckton. Not only are you not a scientist, you're not even a lord who served in the House of Parliament. Isn't that correct? In the House of Lords. Is it correct you did not serve in the House of Lords?
I think I have already answered that one, yes, sir.
Okay, thank you. So we not only have the deniers who have denied this clear science upon which there is enormous global consensus. They cannot only not produce one scientist to deny this clear consensus, they can't even send us a real lord from the House of Lords. Now, I think that says a lot about the status of this debate, which we should not be having, because we have an overwhelming consensus. And I note that it's not just by these four scientists. Joe Barton, our good friend, asked the National Oceanographic and Atmospheric Administration to review your testimony, Lord Monckton. And this is what they said, quote, "The fact that globally average surface air temperatures has shown no trend or even slight cooling over the last 7 years is not an accurate reflection of long-term general trends. In fact, calculation of a trend over the last 7 years is a gross mischaracterization of the longer-term trend. The last 7 years have been part of a strong warming trend that began in the 1970s, which is attributable to human influences," citing IPCC 2007. During the last 7 years, 6 of the 7 warmest years on record have all been observed based on NOAA's global land and ocean data. Deducing long-term trends over such a short period of time is comparable to estimating the height of a sea swell by looking at the short period waves on top of a swell. Close quote. NOAA, the people who work for our athletic democracies have concluded we don't need a fake lord to tell us not to act. We need real science, and we need us to have a clean energy policy. Thank you.
Gentleman's time has expired. The chair recognizes the gentleman from Oklahoma, Mr. Sullivan.
Thank you, Mr. Chairman. And Lord Monckton, I guess I think you have a right to explain why you are a lord, and I don't think you had an opportunity to.
I'll do that very briefly, because this is not the subject of this hearing, and once again I see politics of a not particularly pleasant kind creeping in. My grandfather was created a hereditary peer, one of the last to be created, in 1957, and by letters patent issued by the Queen. Until those letters patent are revoked, and they have not been, I remain, and am correctly addressed as, the Viscount Monckton of Brenchley. I am, therefore, a Lord, but by virtue of the 1999 House of Lords Act, I no longer have the right to sit or vote. That was taken away from my father, so I have never sat or voted in the House of Lords, nor have I pretended otherwise. And I think that really should deal with that matter. Thank you, sir.
Thank you. Lord Mockington, what could climate scientists do to regain the public trust in their work? What can they do to ensure transparency and accountability in the climate scientist community, especially as we look towards the development of the upcoming IPCC's fifth assessment report?
Let me first of all begin with the quotation from NOAA's response to my written testimony, which incidentally I wasn't given a copy of before this hearing, and I think somebody has slipped up there. But the passage that was quoted focused on one short sentence, which mentioned that for the last 7 or 8 years there has been, if anything, a certain amount of global cooling. So there has. But however, my temperature record goes back as far as the Neoproterozoic era, 750 million years ago. The graphs I showed today are for the last 150 years. So I don't think I can be fairly accused of having unreasonably cherry-picked the periods over which I was looking at the data. Now, what I think scientists therefore need to do, if they want to start commanding the respect of the public, because they are losing that respect over this issue, is to stop chattering about consensus. Science has never been done by consensus, and it isn't going to be done by consensus now. Stop using in the IPCC's documents references to documents not produced by peer-reviewed sources, but by green propaganda groups and by journalists, and confine their analysis to the peer-reviewed literature, as I did today. And also, they must make sure that instead of trying to push one agenda and shout down anyone who dares to put an alternative point of view, as I have politely sought to do today, they should treat those who disagree with them with courtesy, hear with some care what they have to say, and instead of dismissing an argument they perhaps don't understand, as one of the panelists here did when asked to comment on my testimony, they should instead engage in a rational debate via the columns of the peer-reviewed literature with the many scientists who disagree with the official line. And of course, scientists could have been paraded here today, but quite rightly the minority group, knowing that the majority would merely want to throw brickbats at them, decided that instead somebody with a certain amount of experience in politics and a thick skin should sit and take the cowpats flung at him, which I'm more than happy to do, so as to spare the many thousands of diligent scientists who are questioning every aspect of this ludicrous scare to get on with their work. And that is what, in the end, is going to decide this matter. It is going to be diligent scientific inquiry and not the hurling of childish political insults.
Lord Mockington, do some of these scientists, or anyone I guess could answer this question, do some of these scientists, how are they funded? Do they get grants, or are there organizations that give them funding? Do you think that that has a potential to corrupt the process and what their data, and do they feel beholden to certain results because of that?
That's a very shrewd point, sir. The only reason why the notion that consensus decides science has unfortunately crept in is that science these days effectively is a monopsony. There's only one paying customer, and that's the unwilling taxpayer. And because of that, and because of the grant funding structure, and because of the resultant academic pressures to conform, it takes enormous courage for any scientist to stand out against the political line that is now being taken among the scientific institutions and to say, hang on a moment, the numbers don't add up. I've just shown you today various points at which the numbers very plainly don't add up. And they are established in the peer-reviewed literature, and they're established by measurement and not by modeling. You've heard the rather qualitative replies of the four scientists here. They didn't really quote numbers much. They were quoting models. But science is best done and most accurately done by measurement. And those papers that rely chiefly on measurement are finding that there isn't the problem that we are told there is.
Thank you, sir.
Congressman Cleaver.
Thank you, Mr. Chairman. Dr. Field, and I may want to get the other three to respond to this as well. I think all of the denials and all of the talk of ClimateGate has had an impact, at least in the United States. In 1997, Gallup began conducting polls on attitudes in the United States on climate change. And tragically, the number of people who believe that climate change has been exaggerated, according to Gallup, the latest poll is 48%. Until the latest poll, the number of those who embrace climate change as being impacted by human activity was on the way up. So the folk who have been fighting this have, unfortunately, and from my vantage point, been winning. The poll also shows that, and maybe this is one of the reasons, that in areas where there was extreme cooling over the past winter, those people polled in those areas tend to embrace the theory that there's been exaggeration. One of the questions that I'd like to ask, even though is what atmospheric condition needs to be at play for a higher level of snow on the planet? Anybody?
Well, perhaps one comment along those lines. Indeed, as I tried to emphasize in my testimony, global warming does not mean that changes are uniform everywhere. There are pronounced regional and seasonal variations, and this is due to the natural variability in the system. We still expect, under climate change, that we will have snowstorms. We will still have cold periods. Cold periods may become less frequent as we go into the future, but they will certainly occur. In terms of some of the heavy precipitation events, as my colleagues have spoken to today, a key ingredient in that is that as the atmosphere warms, as it has unmistakably been observed, the warming, the atmosphere can hold more moisture, and therefore any given storm will precipitate more than it otherwise would have. As we've also been very explicit, that does not mean that you can attribute any individual storm to climate change, but on average and statistically, we would expect to see an increasing trend in heavy precipitation events, including heavy snowstorms, and this indeed is being observed over many parts of the world.
Though it's counterintuitive, the scientific truth is we have more snows if it is warmer.
Yes, again, that relates to the ability of the atmosphere to hold moisture. A warm atmosphere can hold more moisture, so
yes.
When it does snow, it will snow more.
Dr. McCarthy.
Thank you. This is a very complicated subject, and one can take one little piece of it and make a headline out of it and find that it's maybe true, but sounds like a contradiction. So the place I live right now in the Pacific, I used to live in the Pacific Northwest, in the Northeast, what limits snowfall in the winter is not temperature, but moisture. And that moisture may come off the Atlantic with a nor'easter, it may come up from the Gulf, or it may come off the lakes, the Great Lakes. So one of the early projections in climate models was that in a warmer world, we would have more snow accreting in Greenland and in Antarctica. Now that, to many people, sounded like a contradiction. But indeed, for exactly the reasons that Dr. Hurl just explained, a warmer atmosphere holds more moisture. The air comes off the ocean over Antarctica, over Greenland. Now, early studies showed that that was indeed happening. not possible until we had very precise estimates of the elevation of these ice masses with satellites. But what we see at the edges, even though they're gaining snow more rapidly, Antarctica, it's the coldest continent. It's also the highest average elevation of any continent. It's the windiest. It's also the driest. It's our biggest desert. So as the ocean warms up around it, more moisture in the air, more moisture into the interior. But what we see now, as you look more carefully, is it's gaining in the middle, but it's losing at the edges. And on balance, Antarctica and Greenland are losing ice more rapidly than it's being formed. So you can take any, back to where you started with this comment, any sort of one of those short phrases, you could make a headline out of it. And often the public is very confused because they see these fragments of information and don't understand how they fit together.
Yes, thank you. That's important, and I don't know. One of the things we've got to do is to be able to figure out a way to present complicated information in I think the newspapers are supposed to be printed at a 6th grade level, and I think something as important as this, we've got to figure out how to simplify the language for the public, because otherwise they're going to get a headache and bail out, because they're not concerned, but they don't get it. Now some of this we learned in 8th grade, but my frustration is simplifying the language, and I don't know how to do it.
Could I make a further comment?
Yes.
Consensus seems to get a bad word at times, but when decision makers come to groups of scientists and say, tell us the simplest version of this story, that's where the consensus statement comes from. If you get scientists together and say, what do you want to talk about? We don't talk about things we agree on. We talk about the parts that we disagree on, the things we don't understand, where all the interest in furthering the science lies. And so if you made 2 rosters and say, where are the statements on this subject that say there's a problem because the climate is changing, we know the causes of that. If those trends continue, all of the sort of impacts we talk about will come in play. Who's on that ledger? All the National Academies of Sciences. In my testimony, I included a statement that came out last October. 18 organizations, scientific organizations in the United States, look at any of our societies, the American Meteorological Society, the American Geophysical Union, American Ecological Society. All of their statements are very similar, and I've given an example here. So we're asked at times to try and simplify this, and this is the consensus, or where consensus comes in play. Scientists don't sit around talking about what they agree on. They talk about what they disagree on.
Thank you.
Thank you.
Thank you all. The gentleman's time has expired. We're about to be summoned to the floor with bells and whistles for our robust democracy on the floor of the House. We deeply appreciate your coming here, and I think any review of the record today, the materials you've submitted, I think illustrates the purpose of the hearing. But you've been so patient with us. We want to make sure that, and I apologize for trying to bring it to a conclusion, but we would like to give every member of the panel a minute and a half just for any summary conclusion that you may have, any takeaway, if you've decided that it was just cloud cover and you were wrong. Any wrap-up thoughts?
Sure. I'd appreciate the opportunity to make some concluding comments. I think that transparency in process, making data available, making model codes available is extremely important, and that is something that by and large the climate science community does a very good job of. I work at the National Center for Atmospheric Research in Boulder, Colorado, where we develop one of the world-leading climate models in the world that is used to understand climate as well as project future changes in climate. And that entire code and all of the data that go into that model are publicly available. You can go out to the website right now and download that data. And I think that climate science, spanning the breadth of the sciences, makes a very valiant attempt to be as transparent as possible. I also want to emphasize in terms of the IPCC process that it is indeed an assessment, and As Dr. McCarthy pointed out, the consensus view is indeed a very powerful view. The IPCC report does an exhaustive job documenting not only what we do know, but also what we don't know, and where the grand challenges are, and where the uncertainties are. There are many, many peer-reviewed papers that are thoroughly assessed in those international assessment reports. When we saw some of Lord Monckton's evidence today, those are largely based on single studies, and I could take the time if you wanted to go through those on an individual basis and point out some of the flaws in those studies as well. That's the scientific process. And indeed, for the papers that he has highlighted, there are other papers in the literature that counter those points and raise issues. So, and very quickly, the final last word, what I did not address was indeed the importance of communicating, and I thoroughly agree that is a very fundamental, very critical thing that all scientists need to be doing.
Thank you. I'll try and make 4 points very briefly. One, to emphasize a point that I made in my testimony, that what we're talking about here are not just changes that we may see analogs for in the past, but very, very rapid changes, rapid rates of change, rapid rise in sea level, rapid changes in ocean chemistry. And that's a very, very important part of the message. Secondly, I'd like to say that we should think about this like assessing risk. What if we're right? What if we're wrong? What's the worst thing we could do? And I think you puzzle your way through that logic. Think of how we assess risk, whether we buy fire insurance for our houses or not. I don't think my house is ever going to burn down, but I would not own a house without fire insurance. And we assess the risk here. We say, could we err on the right side or the wrong side? I think we want to err on the right side. Then you look at all the projections for costs, and increasingly from the report from Sir Nicholas Stern and many others, you see that doing the right thing to move us away from dependence upon fossil fuel is not inordinately expensive, and there are enormous benefits, many of which have never been costed in this ledger. Then, just finally, if you go through these exercises, you see that we have a limited period in which to act if we're going to avoid some other things we didn't even talk about today, some of the high consequence, low probability, high consequence changes. And if a lot of models show that if we do not act within the next decade to begin to bend these curves, then we're entering dangerous territory. Finally, we all need to communicate better. Scientists are clumsy at this. It's not our profession. We learned how to do science, not how to communicate well, and we need to work on that.
The central point I should like to leave the panel with is that there is no hurry. If you do nothing about this at all for the whole of the next 23 years, the worst that will happen, using the UN's own estimates, is a 1 Fahrenheit degree warming, which will be largely harmless and beneficial. So you have plenty of time to check the studies, just a few of which I have shown you today, in the peer-reviewed literature, suggesting that there is another side to this story, another side based not on modeling but on measurement, which establishes, and is with increasing clarity establishes, that there is no scientific problem. Even if there were, adaptation, as and where and if necessary, would be orders of magnitude cheaper and more cost-effective than trying to stop the emission of carbon dioxide. Who is going to get hurt if you start closing down coal-fired power stations, putting up the price of gasoline and electricity? Who is going to get hurt? It is the working people of America. Is that a good thing? I don't think so, and nor should you.
Thank you very much for the opportunity to make a couple of concluding remarks. One of the things I think really needs to be emphasized is that the scientific evidence on climate change is based on many lines of independent evidence, on thousands and thousands of scientific studies that are quantitatively careful. Some are based on models, many are based on observations, and they all fit together in a fabric in which the general kinds of conclusions that indicate that climate is changing, that the changes are important, are very, very real. It's also important to note, however, that there are important unknowns. Some of those have been discussed today, and many of the unknowns are in the direction of risks that are potentially higher than we have been able to accurately categorize. The risks of sudden sea level rise, the risks of carbon release from ecosystems, and the risks of dramatic changes in the Earth system have all been very difficult to quantify and are not generally recognized in the more conservative kinds of assessments that typically come from the IPCC and other organizations. I also want to emphasize the point that Dr. McCarthy made about the importance of viewing climate science as essentially a problem in risk management. We don't know precisely what the future will look like, but we have a very clear picture of the risk elements that are introduced by changes that people are causing in the Earth's system. And we can have an increasingly clear picture of the consequences of common sense investments in decreasing those impacts. Now, finally, I want to conclude with a very strong comment that Lord Monckton's conclusion that we don't need to do anything now is fundamentally misleading. We haven't seen crises that we can unambiguously attribute to climate change, but we have seen increasing risk to a wide range of Earth systems. And we also know that the longer we delay, the more difficult it gets to address the problem, and the more expensive it gets. This is a problem where common sense investments in the shorter term are likely to pay big dividends relative to waiting and hoping against hope that the situation isn't as bad as the science indicates.
Great. Thank you, Dr. Field, very much. Dr. Grumlich.
Thank you for the opportunity to make a final comment. I would like to, first off, simply agree with my colleagues on this panel that the scientific consensus is clear and that the urgency to act is very much upon us. But I'm struck by Congressman Cleaver's comments about the degree to which public perception is perhaps lagging behind the perceptions of some of you on this particular committee. And want to give my view from the Southwest. I am part of a land-grant institution that has a very strong relationship with the ranching community in the Southwest. Since 2002, we have been in a deep drought, and there's very good scientific evidence that that is due to the northern migration of the westerlies that are no longer bringing as much precipitation to the Southwest as there was before. Our ranching community is not arguing about whether climate change is here or not. They are coming to us saying, what are we going to do about it? And climate is the number one issue in this community, and they are asking us to give them guidance about how to adapt both in the short term and the long term. So I think that the public perception that climate is an issue, whether it's called climate change or whether it's not called climate change, is particularly keen among the peoples of the Southwest. Secondly, as a professor in a large public university, we share your concern about the increase in scientific literacy that is going to be demanded to address the complex trade-offs that we are coming up against, and we are very much engaged in that enterprise. Thank you.
Thank you, Dr. Grumlich, very much. We thank each of you for your participation in this very important hearing. We will continue with additional hearings on this issue so that we can ensure that all of the science is out in a way that it makes it possible for the public to be able to make an informed decision as to whether or not there really is such a thing as global warming that has been caused by man-made activity. We think that there is no more important debate that we can have in the Congress or in our country. And the experts that we had today, I think, very clearly laid out the scientific reality and has only added to my conviction that we have to act, and we have to act soon. The Waxman-Markey bill passed last June 26, 2009. The Senate has a bill which, with a little bit of luck, it will begin consideration of in the relatively near future, but time is of the essence. So with the thanks of the committee, this hearing is adjourned.